Okay. Okay. So let's start. We'll be talking today about the going from CRUD to CQRS in practice, and we'll see whether this is really something that we should be striving for or not. I would be curious your thoughts at the end of the webinar. So we will try to crunch and tackle the common misconception. I mean, I already gave the spoiler because I think that they are kind of misconceptions, but we'll see. So the most popular is that the CQRS requires multiple databases. We also try to find out whether it really introduces eventual consistency, or can we do CQRS without event sourcing, or even without DDD. And we will also have a look if we need Kafka, RabbitMQ, or other message queuing system. And the last one that I will be especially curious your thoughts at the end of the webinar. So whether CQRS really brings much additional overhead to the regular implementation. But of course, sorry, I should start from explaining those weird acronyms. I think that CRUD you for sure know. So it's of course create, read, update, delete. And as you for sure know, that comes from the name of the most classical and typical methods that we are doing with our data. So we can create, then we are updating a few times, reading it, and sometimes we are deleting. And what's CQRS? I'm always joking that CQRS is like a Sasquatch or Nessie. So everyone heard about it. It's kind of one of the buzzwords. So everyone's heard about it, but not many people probably saw it, at least in the classical definition. So let's continue to trying to understand what CQRS means. So before we go with this additional R letter, let's start with explaining what's the CQS. Because CQS was the original pattern that was designed by Bertrand Meyer, and he came with this idea while he was working at yet another useless language called Eiffel. But I think that the most important idea that came from this works is this pattern. And Bertrand Meyer found out that it would be great if we could split and separate writes from queries, because he said that asking a question shouldn't change the answer. And in general, he coined that a command is some kind of procedure of running some business logic, of course, intending to do something. And by doing something, of course, most of the time we mean storing some data as a result. And query is just a function that takes on parameters and returns a result, but it shouldn't change the state. And because of that, we have a clear intention of what we want to do, and we have separation of concerns. And because of that, that makes our logic, either command logic or query logic, more predictable, because we don't have nasty surprises like accidentally changing something while asking and doing the query. And CQRS, finally we reach to that. And CQRS is a command query responsibility segregation. What's important is that we change separation to segregation, because Greg Young coined that term, I think 12 years ago. So quite old buzzword, I should say. And Greg Young just took what Bertrand Meyer described how to structure your code, because the CQS is more like how you should write your code. And Greg took the CQS, so those separation of writes and queries, into the architecture level. So Greg told that we should not only design and write our code to be either running some business logic without returning the result, or doing the queries. And if we focus also on those methods to do some specific business intention, that makes it even better. And I think that this is the critical part. So objects are split into two objects, one containing the commands and the other containing the queries. So nothing about storage or data model, right? But I think that the main confusion that came from that was this small word objects. Because when we think objects, then we typically think about the data model like entities, aggregates, tables. But what Greg meant by objects was that we should segregate the behavior, so writes and queries, into separate objects, but those objects mean, for example, domain services, query services. So this is kind of unfortunate to name it objects. And unfortunately, Greg doesn't do much updates after he writes something. But on the other hand, people, what they took from this rather short document that he wrote, so CQRS documents, was this image. And if we have a look on this image, not even looking at what architecture it describes, we can notice that this picture that is showing two separate data storages that are eventually consistent and have everything broken down into two separate paths is a 12th image in this document. And before that, right before that, we have such images. And on the right side, so here, we have how the write logic could look like. So this is nothing spectacular. We have some API, then we have the facade, so our, for example, controllers, some application service, and here we have our domain objects, and then we have storage. And on the left side, we have how query side could look like. So we have some API, and we have free read layer. So where we are running queries, typically right away into our storage. But no one told, and especially Greg, at least in his document, that those two storages couldn't be the same storage. So I think that this is where the original confusion comes from. But let's see that in life. So what we're going to do right now is we're going to try to prove that you can do CQRS on the same table, even on the typical CRUD-ish domain. So the first example that I show you, and this will be a lot of code transformation. So I'm joking that it's like in the Power Rangers, so morphing time. We will be doing a lot of morphing. So if you see that for some reason you got lost, or you just blink and I changed too much, or I showed too much, then feel free to interrupt me and ask questions. I will also try to make a short break after each transformation, so we could be sure that we are still on the same page. But yeah, let's start. So as you can see, we will be doing a part of e-commerce domain, not surprisingly. And as you see, we will be working around the products management. So products definition, etc. So typically the most CRUD-ish example. Let's start from the top and try to understand what this code is doing. So we have controller, API controller, that is deriving from some base controller. We'll get into that. And it's using some service. And as we can see, it does create, update, delete, get by ID, and get page data. So as typically with the CRUD-ish layered architecture, it's hard to understand what's precisely going underneath. So we don't see where are we storing this data, what tools are we using. So let's try to go deeper. Let's maybe before we do that, let's see how the code structure looks like. So we have controllers, we have some model, okay, we have product, we have some repositories, services, classical onion architecture broken down by layers and the class's responsibility and not the business process. But okay, let's see what I'm using underneath. So let's check the CRUD controller. So typically, like we would be a developer that is getting into the code base, have some feature to add or modify and trying to understand where we should add or change the code. So we have CRUD controller, which has some CRUD service, not surprisingly. And then after we are just calling methods from the service. Again, we are sending some requests, expecting some response. If it succeeds, then we are returning okay. So CRUD controller is just a thin layer for the services. So typically we are doing that to reduce the repeating ourselves. Okay, let's see what service is doing. And here we are reaching the first boundary and yet another level of indirection. So we see that we have CRUD service that also have the base operations that we expect from the CRUD service and CRUD domain. Let's go into the implementation. So not surprisingly, in this layer, we have another layer. So we have also the repository, which will be probably doing some operations on the data. And we have also mapper. This is from the automapper. So I think majority of the people at the webinar are from the .NET community, but this is just to do some magical mapping of the request to entity. In other environments, you have a similar tools probably. So we are taking create request, then we are mapping it to entity, and we need to have some magical mapping because if we are creating generic service, then we don't know what to expect. So we don't know precisely what data we should expect from the specific request. So then we are adding entity, we are saving the changes, and then we are returning the updated data using the get by ID, which we are also using for queries. And of course, we also exposing the generic query mechanism just in case. And for update, we are doing similar stuff. So at first we are getting the entity, then we are mapping the update request into the entity, storing the updated state, saving changes, etc. And what's also common in the CRUD-based approaches is the number of interfaces or markers or attributes, like if you are from the Java space, then annotations. Because to be able to, for example, get the entity that we would like to update, then we need to use the iUpdate request, for example, to be able to say that, yes, this specific request has ID, and by that we can, once we are in the service, see, I'm even getting lost, but that's expected. So to be able to get the entity by ID, then we need to know that. And what's also quite common is that we are doing a lot of potentially redundant operations. So here we are getting the whole entity, then we need to provide also the whole new state. We cannot, for example, say that we would like to just update the name. No, we need to get the whole entity, then update the whole state, and also then we need to query just in case we modified something, we have some auto-generated data in our database. So let's see what's happening inside the repository. And inside the repository, it's again not happening much more. We have the ORM, in this case, entity framework, which is the most popular in the .NET space. And we are just wrapping this ORM with our repository, just in case we would like to have some additional operations. So as you can see, we have controller, service, repository, and ORM. And ORM, in fact, at least nowadays, ORMs typically implement the repository pattern. At least the entity framework in .NET is doing that. So what I try to show here is that if we are doing CRUD, then in my opinion, it's not that we will immediately know that what's going on and that it's super fast. It's super fast as long as we precisely remember the conventions that we are using and that we don't need to do any additional operations. Because if we need to do that, then I'm almost sure, because I was doing that in the past, you would have methods like on before create, on after create, on before update, on after update, just in case you need to customize some additional behavior. And because we are splitting our code base, not by the business features, then if we need to, for example, add new endpoint, then we need to go through all the possible layers and classically also from all the base classes to understand where do we need to apply that. So of course, optimistically, we can just derive from the generic code and we will get everything for free. But this for free is only during the design, the first implementation. Later on, it's getting much harder. So let's have a look if we could make it CQRS approach here. I have example. We will be still doing CRUD, but this time we will try to segregate operations from writes and reads. So to do that, the easiest way to tackle that is to introduce another service. So right now we have service for write model and service for read model. And service for write model doesn't change much comparing to what we have before, but we don't have any more operations for querying data besides getting entity by ID, because when we will be doing the create, update or delete, then we will still need to get the entity that we want to modify. But let's have a look on the read service and read-only service. So I just took those methods that we had merged into the specific service, but I move it directly to another service. And what we get from here, let's have a look on the implementation of the read-only repository. And here, we don't need to inject the whole DB context, and DB context in the .NET space is the entity framework ORM, the main class. We can, for example, inject just the query for the specific entity type. So we are intentionally limiting ourselves, because then if we are using this repository, then we won't have any chance to modify data, because what we have here is just queryable, which is just interface that do not allow modify operations. And what we also get, even by this really basic split, is that when we are configuring what we are injecting, then this is the configuration.NET how to inject and configure the IOC. So what we are saying here that we are using this ORM with this database context, and for products, we can use as-no tracking, and this will return the iQueryable. And as-no tracking means that as long as we are using this iQueryable, so this one that we inject into the read-only repository, then we won't be doing and trying to track any changes to the entities. And even because of that, we are getting immediately the micro optimization, because if we disable change tracking, then our ORM in this particular case will work much smoother. So again, we are still using the same single controller, because it's not like we have to split all the layers. We can, for example, decide that we would still like to have this application layer or API layer that is orchestrating the behavior. But when we are doing that, then here for the update or changing the state operations, we are using this CRUD service that have create, update, delete operations. But if we are doing the queries, then we will be using here just direct queries from our read-only service. And technically, this is already fulfilling the CQRS definition, because what we did is we segregated the change behavior from the read behavior. And one more change that I did here, I didn't explain that, is that CQRS is stating that we should not be returning the data. And not returning the data is mostly to not tie the read model from the write model. But it's not like we cannot return anything from the API. And previously, as you, I hope, remember, we were just always returning OK status, which is also not great from the perspective of the REST API, because the real REST API is when we are using the hyperlinks. And the classical approach to do the proper REST API is to, instead of returning the result, is to return the location header. So location header is saying that for the API client, that here, if you would like to get and see the updated data, then just do the query for this specific URL. So when we are creating the state, then as you can see, we are not returning anything from the service, but we are returning the the URL to the API and to the get endpoint. The same here. So we are right now, we fulfilled all those segregation definition of the CQRS pattern. So do you have any questions or concern at that moment? Okay, no questions, but so I hope that it's clear for now. Yep, thank you, Dave. So, okay, but if we go and stay with this approach and say that, yeah, we are implementing CQRS, then of course we would already get some small optimization, like a performance optimization. We could also break the controller base class into the write controller and read controller. And that could also give us the benefit of, for example, taking our get endpoints to separate API and also having the different scaling, because in majority of applications that we are creating, reads are much more often than writes. So for example, we could scale reads differently, and especially the CQRS part, or that queries are not modifying the state, are great for scaling because they are stateless. So we are just querying, so we can put in parallel many instances of the read operations and have the better scaling. But even that, it's not that this is a great achievement, because this could look a bit like a bike's heading, because we didn't change a lot in our approach. We are still doing CRUD, but right now we are doing CQRS CRUD. So let's go deeper. So the first step that is typically done, and what a lot of projects, including my own from the past, are stopping, is that instead of keeping the single structure and the single project for the API, we are distilling it and taking outside the project, which is typically called domain, business, or whatever we prefer. So I did that. It's nothing fancy. I didn't change anything in the code. So here we have our database storage code. Here we have, I introduced the breakdown for the basic module, like a products module. And of course, I moved some of the core classes. Some stayed here, some were kept here. So the controller class. But besides that, nothing's changed a lot. It's a bit better because we are getting some domain information. So for example, instead of going through all the possible layers and having all the services within the services folder, if we are modifying the product logic, then at least we are staying within the same tree structure, but inside the product scope. So this is already a bit better, but it's not enough, in my opinion. At least that's my current way. So let's see what we could do better. So maybe let's have a look again on our services. And so our services are calling repositories. It's doing some custom things like doing the mapping. So maybe that should stay for now. But if we have a look on the repository class, then having such repository, at least in the context of the entity framework, is just dumb, because and this ORM is already having some interfaces that even if we would like to, for some reason, unit test that and mock it, then we can use it. We are not doing any much magic besides doing some basic checks. So maybe we could just get rid of this repository and just cut the one level of the indirection. So let's have a look how our service will look like for that. So instead of having the repository injected, we are injecting the ORM that we are using. So in any other environment, this would be exactly the same. DB context is the entity framework, so the .NET ORM. And instead of having the repository, so always needing to have additional class deriving from the repository, we are just using the methods that ORM is giving us directly. Well, okay, I cheated a bit. So I added some extensions. So in a .NET space, if you are, there is a possibility to say that if I have the object of the specific class, then we can wrap it and add some additional data. So like we are extending this class by some additional operations. But even if the language that we are using doesn't have such approach, then we could just use a wrapper class that could could compose some basic operations. So let's have a look what operation I added. So for example, find by ID, I wrap it because I don't extremely like this syntax from the entity framework. So it's just getting the ID entity by ID. And I also added the method that is called handle and save changes. And handle and save changes allows us to inject function that will be doing something. And then we are calling the save changes to be sure that whatever we did with this handle method, then we will be storing the results. So for example, if we would like to update and save changes, then update what typically how the flow is looking like. So at first, we are getting the entity by ID, and see, I'm not injecting any magical interface. I'm just injecting the straightaway ID. Then we are typically making sure that this entity exists. If it doesn't, then we are throwing exception or returning result. After that, we are running some logic, and we are getting updated entity that we are storing in database. Same for deleting. So we are getting entity, making sure that it exists. And if it exists, then we are removing it. So nothing spectacular is going here. And here, so, you know, for add, we are not doing much currently. We are just adding entity, but maybe in the future, we would be having some more stuff. But some could say that, what's the improvement against the repository that we had before? So in my opinion, the first one is that we are not getting the inheritance. So we don't need to adapt and immediately implement all of the possible methods that the repository owner had. Instead, we are getting a smaller methods focused on the specific operation. And as we are providing option to pass some handler functions, like the callbacks that will be doing the logic, then they are quite elastic. So instead of having the layered architecture, we are building our code base from the smaller blocks, like Lego blocks. So composability allows us to have a smaller code and more flexible, because if we, for example, even if we derive from the service, then we still have access to the DB context. Oh, well, right now we have the access, and if we'd like to, then we can use one of the smaller methods, composable one, or even use a direct API for the ORM. Of course, it's like we need to check, and we need to decide how much control do we want to have on our friends and on our other employees, because with the great powers comes great responsibility. But in my opinion, if we cannot trust our devs or ourselves that we will cut some during the code review, then we have some additional and another organization and issue that we should try to fix in the future. So again, what I did is that at first we broke down the services into write service and the read-only service. And right now I got rid of this additional redundant layer of the repositories. And instead of using the inheritance, I used and composed the code from the smaller building blocks, enabling us to customize our behavior, but still having some conventions and having some code to base on. So do you have questions at that moment? Should I elaborate on something or explain? Nope. Thanks, Rafał. So don't be shy to ask if something isn't clear. So as in the inception, we need to go deeper. So still, if we have a look again on our, let's go back to the previous example. So if we have a look on our service layer, then nothing spectacular is happening here. So before we had the, sorry, not this one. So you got already spoiler. Sorry for that. So if you have a look here, then what we have here is nothing spectacular because we have still just a wrapper for the additional, for the DB context. So for our ORM, and the only thing that we have additional is the usage of this auto mapper. So this magical mapping that is changing our requests into our entities. So here we are mapping the request to get the entity that we would like to add. And here we are updating the entity that we got from database based on the request that we have. So, and as I mentioned, we are doing that just because we don't know what to expect. And if we'd like to understand how our logic look like, then it's still really hard, because if we have a look on the implementation of our service, then is this implementation telling us anything, what's happening? We need to always, when get back to the base class and try to understand that, especially that, you know, this code tend to change, and we need to then try to understand whether someone in the meantime didn't change the base implementation. But okay, we see that, okay, there is some mapping, and we can try to search. Yeah, we have such entity. Okay, again, we have this marker interface just in case. And maybe let's have a look on config. Yeah, so if we would like to understand what our service is doing and what's our business logic, so-called business logic, then we need to go to the mapping configuration and see that, okay, so we are mapping that by conventional based, and those two fields we are ignoring. And then we need to try to understand why are we ignoring them. And of course, we can get into the conclusion that ID should not change, and the product number is something that is set during the creation time, then probably we should not change it. Okay, so let's try to have a look what we could do about that. So what I did, and right now I'm in the next example, so explicit domain. And as this example is named, then it's precisely what I did here. So I got rid totally of any magical auto mapping. I just included not the base class. See, I removed the base class. I injected explicitly the specific ORM configuration for our e-commerce. If you're not from the .NET space, then typically when we are defining the database in the entity framework, then we need to create such class that have all the configuration. But it doesn't matter much in this time. Think about that this is the ORM, the specific ORM configuration. And what we have here is we still have those methods like create async, update async, delete by ID, etc. But here we don't have any magical generic methods, generic parameters. We just have the explicit comment, and we have the explicit mapping, and same for update. So what we have here is we have the explicit mapping. I got rid of this auto mapping configuration, and here we are saying that, yeah, we just want to delete and save product with the specific ID. So controller did not change anyhow, but here we are getting the service that is still short and still small, because we are doing rather generic, the basic logic. We are using the composability, so those smaller classes, but see, as we know precisely what's our business flow here, then if we'd like to, then we could add something here, some additional logic. We could do the customization. We wouldn't need to trying to figure out whether we should keep that in our base class or we should have it explicit. And this code already is saying us precisely what is happening with our product on all of those methods. And the same I did for the queries. So instead of having the base class, I'm injecting the query interface, and I'm doing the mapping explicitly. So I'm saying that if I would like to get by ID, then I expect to have a bigger details response. And if I'm doing paging, so potentially for the list endpoint, then I expect to have the shorter, smaller information. And this is how I'm mapping that. And when I was preparing this talk, then I looked back in the past. And in my opinion, the way that we were shaping our and why the CRUD-based approach is popular is that like over 10 years ago, when I was starting, like over 15 years ago, like the unit testing, even if you even try to unit test .NET or Java even, it would be extremely hard. This wasn't so popular at that time. So the only way that you could make sure that what you wrote is good, then you would try to generalize things. Because if you have this generalized code, like the centric code, then you could more or less test it either manual or try to write some automated tests. And you had more trust in this generic mechanism. But right now, the testing approach, the quality, the CI, CD is much better. And also the understanding on the development teams, how quality is important is much different. Then in my opinion, we should really start to be focusing on the explicitness and trusting our code and writing the explicit tests. Because for me, the code is not only, of course, the main intention for creating code is to make it right, to do something. But on the other hand, the code should be also a way of documenting things, because that helps us to understand, to be more efficient, and also to understand the business logic better. Of course, with this particular example, there is not much business logic because it's just a simple create, update, delete, but it's still much easier to customize that in the future than having this layered architecture madness. Yeah, I don't like layered architecture, sorry. So to summarize, what I did here is that, again, I cut yet another layer. So I cut the base classes for services and make the code more explicit. And I think that the code is still short and concise. So it's not like we are getting much more code that we had before. Because those code was also somewhere. So any questions or feedback before I go for the next phase? Thanks, Dave. Any questions, comments? Okay. Morphing time. Yeah, we'll do another morph. And so this is still better. Yeah, I mean, the automapper was also for me one of the libraries that I was adding as the first stage during the setting up the .NET project. So, I mean, in some cases it might be useful, but right now I'm not adding that anymore. So sorry, Jimmy. Okay, so let's see what more we can do, because what we have here is still rather CRUD-ish approach, but I think a bit more explicit and, in my opinion, cleaner. But still, with this explicit domain, we still, if we are looking at that code, then what we have here is the first step is the business, but inside we have again split based on the technical layers. It is not extremely bad, but if you'd like to, for example, create new feature, then probably you would need to go through all of those folders again and try to understand where to put what. So we will do yet another transition. And here, instead of having the split for the technical layers, we will be slicing vertically our business domain. So we still have, as you can see, the product service, but we don't have much of a business logic here. So as you can see, we still have the commands that we are making some business changes, like create comment, update comment, delete, etc. But instead of that, we have some magical handle methods. Let's see what they are. So I just took the command class, so for this create product, and I took the handler, so the business logic handler outside of the service to get the split for a domain logic. See, there is no infrastructure code here. It's just a pure code. So this code is really easy to unit test. And the same for update. So in the create, we just have the create command because we don't expect the product to exist. But in the update product, we have the existing product, and we also have the command to change the state. And as a result, we are updating returning the updated product. And of course, this is still extremely simple. So someone could say that this is bike heading, and probably this person would be right. But this is precisely the same pattern we could use for much complex logic. And what we are getting here also, and for people from Java, this might be a bit too much, but in my opinion, it's fine to put more than one class within the single file, because if we keep here in the same file the command class and also the handler, then this is the code that typically is changing together. Because if we are, for example, adding new field to product, then we probably need to update command, and we also need to update the handling part. So by having that, we are getting less context switching. So if we know that we need to just extend the update product logic, then we are going, okay, domain, products, updating product. Yeah, we're here. So it might be even possible that we can just update the logic here and call it a day. Maybe we also need to modify the product information, but still we have all at the same place. Do you need the folders? That's a good question. I've been asking myself that question also. We could do it, but then I like to have folders because in IDE it looks better. If I just put those files outside, then I would have just a line of files that visually would be harder to see the difference. But you don't need folders. If you'd like to, you can keep it like that without folders. This is just my personal visualize preference, just to be able to quickly map where are the business logic or the queries, and where are the regular, so-called regular files. But yeah, it's up to you. This pattern, by the way, is called feature folder, and surprisingly, I learned to use that I changed my mind from the technical split inside of the business boundary to this approach when I was working as an Angular developer, not the Angular JS, the old one. I was extreme hater. I really hate till this day. I'm even getting furious when I'm thinking about coding in Angular JS. But in the new Angular, so not so new, but the Angular, there is a really good modularity. So within the specific folder, you are not only keeping the HTML files, so the view, you are also keeping the component, so the logic for the view. You can also keep the tests within the same file. In .NET, unfortunately, that's not possible. But if I'm coding in Node.js, then I would keep also tests within the same folder, because then it's really making your work extremely effective, because it's like having the mobile. You want to check the email because, or you got the message from your auntie, and then after 50 minutes, you realize that instead of answering your auntie, you are just checking the Instagram or Facebook or other social networks. And exactly the same is within our code base. If we need to, let me get back to the initial CRUD example. If you need to jump from one folder to another, then you are getting tired and you are losing the context. But here, it's a bit better because we are keeping the things that are changing at the same time together. Then we don't need to do so much context switching. And some people ask me whether we should keep queries within the same folder. We might not. It's up to you. Probably if we would be also splitting the deployment for the queries to have a separate deployment unit, then we could move it somewhere else. But also, if we keep this split like we have here, then, you know, it's extremely easy to just take this specific slice and move it somewhere. And in my opinion, that's the essence of the CQRS. So we are just making things easier and we are focusing on the business domain. And because of that, we are getting much more options. Because, for example, let's say that we have get products handler. And right now, instead of querying directly into relational database, we decided that we would like to have some fancy full text search. Then we could introduce Elasticsearch here. And of course, it wouldn't be just change here. We would probably need to also define some configuration here and do some migration, etc. But from the code perspective and where are we changing and what are we changing, we don't need to change all of the layers, and we don't need to change all the base classes or think how to put it somewhere. It's like the Pareto rule, because, you know, we could keep even 90% of our code base using the generic base services or repositories implementation. But as long as we are keeping this slice, then we are able to do the optimization for the business logic that's the most important, that is core for our business. So if we would like to, then sure, we could keep most of the modules, for example, even the products module as a pure CRUD approach. But if we have this split, then we could at least, when our business logic grows, or we realize that we would like to do some optimization here, then we are able, without changing the whole architecture, the whole core code structure, etc. So it's about having more choices and more options, and being more elastic and being able to evolve or to morph like I'm doing right now. Questions, comments, concerns? Nothing right now. So we have yet another morphing time. So here, I didn't change much, but you may notice that I removed the services. So where did I put them? Handlers didn't change much. So they are here. So because if we have a look, once again, let me find it. So if we have a look again on our sliced domain and our services, then they are not extremely smart, right? They are not doing anything besides wrapping e-commerce DB context, so our ORM, and calling those smaller composed messages. So why do we need this service? Well, we don't need them. If we'd like to, then we could split also our controllers and don't use services and put the database and our ORM directly into our controllers. And I know that for some of you, that might be already too revolutionary. And quite often I'm being asked on various community channels, like, what's my opinion, whether this should be in the infrastructure layer, application layer, or other type of layer, or super layer. And my answer is that, why do you even care? Because for me, the most important is to have distilled the domain logic, the domain part that we are able to unit test and just keep it as much as we can from the technical point code like IO operation, network calls, etc. But then for me, all the other code that we have around domain is to just to orchestrate and to just pipe the user intention into our business logic. So for me, it doesn't matter whether we call it application layer, infrastructure layer, super layer. So here, what I'm doing is just I'm mapping the, as Dave wrote. So I'm mapping the request, because we shouldn't be trusting request. So see, I made it everything nullable, because we shouldn't be trusting what we get from the user. I have an explicit mapping from the request to comment. And here we could have some simple validation like this one, making sure that this data is provided. If we'd like to, we can use some validation framework here also. I prefer, as you notice, to be more explicit. If we have the good composition, then it shouldn't be a big deal. But still, it's up to you to decide. But we have the API request that is specific for the API. For example, when we have the create, then to be able to know what was the ID of the created record, we are generating the ID here. And for the update, we are getting, for example, ID from root and the rest from the request body. So we need to map both of them. This should be like that. And after that, we are getting comment that is validated and that we can trust. And what we need then to do is to, hello?
Bill, you are back.
Yeah, I'm back. I hope that recording is not lost, but we'll see.
That was previously stopped and currently is the new one. So you have probably you have both.
I hope so. I hope so. We'll see. Technical issues. Who would think about that? So what was the last thing that you heard? Hello, what was the last thing you heard? Can you hear me now?
Yes, we can hear you. What was the last thing? Yeah, everyone's speaking.
Okay, then no worries. I will repeat it. So again, what I'm doing here is that I'm mapping the API request into the command that I can trust because it's validated. And then I'm just calling this wrapper that is getting the entity and is calling this handling logic on the entity. So the handle is exactly those handlers that we have here. So we got rid of yet another layer. And because of that, we have here just our entity definition and the supporting either business logic like creating, updating, or querying, so getting by ID, getting a list of products. Any questions, concerns to that?
Yeah, I think for me, it's just the split between, if you were to write a test, now you're kind of almost forced to go for the HTTP layer, or you have to kind of duplicate the code that's in the controllers.
Mm-hmm.
And that's the only concern I'd have. Like I like to have maybe a dispatcher or something like that in the controller, you know, so you can push some of that code into a dispatcher.
Mm-hmm. Yeah, so
that's the only comment / concern I have with that version.
Mm-hmm. Yeah, the other thing that could be not great here is if we would be able to call this specific command both from the API, so HTTP and API, and some other integration like message bus, etc. Then we would either need to duplicate that.
Yeah, exactly.
Or,
that's the concern.
Mm-hmm. Yeah, but so how would I approach on testing that? So the handling methods, I would just unit test because this is our business logic. We could have the aggregate here or whatever we prefer. The extension methods, so those composable ones, I would have, of course, integration tests, because in my opinion, there is no point of unit testing if we are just wrapping the ORM. So we should trust ORM or know how it works. Or no, of course, I know that it sounds like famous last words, but we need to put the trust somewhere. And and I don't think that just doing the unit tests and making sure that we are calling some methods will give us enough trust, or at least it wouldn't give that to me. So I would test that the business logic with unit tests, and the rest I would test with the integration tests. If I would like to be sure that the business logic is integrated and working as it should. So as we cut a lot of layers, then that shouldn't be super hard and super consuming, especially that the databases like the Postgres image is really thin and really fast. For example, in Martin, I think that we have like 15,000 of tests or maybe more, and it's just running a few minutes on the GitHub actions. So I think that it's doable to do it pretty fast. But yeah, I mean, I know that cutting the service layer is might be a bit too much, and I don't want to force you to just ignore and treat the API layer also as the application layer. I know that that might be too revolutionary, and as you, Dave, said, there might be valid cases where you would like to keep that separated. I'm just showing the options. So it's up to you to decide where you would like to stop. But I'm just showing that this is still possible. And in my opinion, this is still fine. And because of that, we are getting like, at first here, the controllers and also broke into the write side and read side. And then we have the business logic slices. So that's how I see that the biggest power and the most aligned approach with the CQRS. But of course, this is my vision. You might have different one. And as I said, this part, this first morphing, this first transition, it was already enough to fulfill the CQRS definition. The rest is just optimization, more focusing on the business logic. Any more questions, concerns, comments?
So maybe one comment from my side. So it fits quite well to what Vladimir Korikov described in his integration test book. So because he wrote that, okay, so the book name is unit test, of course. So he mentioned that we should focus on unit tests when it comes to or domain model. So that the logic that is inside each handle method, and when it comes to integration tests, we should explicitly name our external dependencies, like here in database. So what I'm pointing to is that in your API controller, there is a explicit dependency to the database. So it's quite easy to point that, okay, there is an external dependency. So probably that is a great candidate for to test. Yeah, so the sample here is quite similar to the one gave by Vladimir in his book. So
yeah. Thank you. I haven't read this book yet. It's on my to-do list, but of course I read a lot of Vladimir's article. Not always I fully agree with all of them, but here, yeah, that was also my intention. Like, if you see this code, then you immediately know what tools are you using, what dependencies you have, and what's the exact flow. And if we are not using, for example, mediator, but the code that I use here, then we also don't have this magical references. We can just do the classical IDE, like find all references or go to implementation, and IDE will help us. So it again makes the ergonomy a bit better. So here, when we go as the first one here, then we didn't know anything about the dependencies. We need to go 3 layers down. We didn't know where is our business logic, what is going on here. And here we have that explicitly. Of course, I agree that this requires a bit more rigor, and it needs to be also fine-tuned with the development process. But yeah, it's like the trade-offs we take. Yeah, thank you, Citello. Yeah, so I'm good with having services. For example, Alexis Imarev is saying that he likes to have those services because then by looking at the service definition, then you clearly know what are the all methods that you should expect from this particular part. So I'm not totally against having this layer. I'm just feeling that it's a bit redundant in many cases, or at least in many cases, it just taken blindly by the Robert Martin work. Like in my previous project before Event Store, I counted 7 layers. 7 layers. That was a nightmare with the really simple logic. But yeah, I'm not against. So you need to put where is your pain point, where is too much for you. I'm just showing that this is still possible. So let's see yet another change. And here that would be proud. I think that will be too much. For, if the putting into controller was a lot, then see, I removed even controller. So where did I put it? I didn't put it into this file, but because in .NET, you could build right now the single file application and put the API definition also in the application configuration, but I didn't do that. I did something that for some reason, I haven't seen much people showing in the .NET space, but this approach is really popular in the Node.js space and probably also other environments. So I went to extreme with the slicing our code base, and I put the endpoint definition together within the same feature folder as the business logic. So in .NET, and exactly the same is doable in Node.js. What's more, you could do even the same one in the Spring Boot if you'd like to. Then it's possible to define a specific endpoints and put each endpoint with the separated file. So we are getting here, like we can still inject services from IOC. We can define the data from body or from the root, exactly as we had before. So see, the endpoint is the same one. The body is the same one as we had in the controller. For deleting, we just have the endpoint because we are just calling delete. We are doing hard delete here. And for updating, we are also having the put method, and it's the same logic. It's the same one. Just put it directly into the slicing. And some may say that, yeah, that's weird. And that was also my initial interpretation of that. But see, this is serverless. Like if you have those methods like that, then you can treat them as functions like AWS Lambda or Azure functions or Google functions. It's like, that's why I'm really in love in the serverless, because then for me, serverless is extremely well suited for the CQRS because you are slicing everything and all of the business operation by the business intention, and you can keep the explicit code. And if we have the code sliced here, then we can still use it, and we can even generate Swagger. We can put it in the specific API endpoints. But if we'd like to, we could move this logic to any other project. We could call it and configure it. And for example, just even reference the whole project, but have the different endpoint for getting products. Because, for example, we expect that a lot of people will be searching for products, etc. So we would like to be able to scale it differently than other endpoints. So this is making our code like reaching the potentially the full flexibility. Of course, it's not the approach for all. Because it requires the composability and the good modularity, and also the people need to understand why are we doing that? Why do we want to keep the code explicit? Because if we put it into big, not modular project or really big monolith, then of course, it will be hard to find the specific endpoints and understand what's the API definition, etc. But on the other hand, we can generate Swagger, so open API for all the endpoints and read it from there. So that's also not a big issue. But I agree if someone would say that it might be harder to find the API definition. But on the other hand, usually when we are working with the code, then we are either adding new feature, so potentially new endpoint, or we are changing the specific endpoint or specific business logic. And I also added a bit more to show you that the flexibility and the business logic is more. So for example, we could add yet another module like shopping carts. If we'd like to, we could use the aggregate pattern. So have the business logic and all of the data that is like together, and have some more sophisticated, again, not extremely sophisticated, but a bit more sophisticated logic. And we could even publish some events, and having the this split is also making that easier, because if we would like to publish or enqueue only specific set of messages, then see, we have the same logic, but what I did here, I'm also injecting the outbox interface, which you can think like any other messaging platform that you would want to use. And I could also publish the events and integrate that with other modules, with other endpoints, etc. So this is really flexible approach. I could also have the modules, nested modules, etc. So as I said, the main intention is to have more option, more focus on the business project process. And as you see, it's even possible to implement CQRS on the same table with the strong guarantees, with the ORM, etc. We don't need all of those fancy tooling that most of the people are mentioning. So do you have questions, concerns around this code? Okay, so let's get back to the slides. And so let's just summarize. Does CQRS require multiple databases? Well, it does not, because we can send a command and query the information from the same table. We could break it. Like if we, for example, our order uses more than one table, and it usually does, like an order table, order item, etc. Then we could, for example, create some view that is flattened, or we could create some dedicated query. And still, if we are using regular views, then we are still getting the strong consistency. We could decide that, for example, we would like to introduce the read replica or materialized view to have better performance. But when we do that, then both replication and materialized views typically means that we are introducing eventual consistency. But we are introducing that not because the CQRS tells us that we need to have the eventual consistency and we have to do that, but because we want to optimize that and we want to have the better performance. So it's up to us to decide whether we would like to do that or not. And we could even synchronize, as I mentioned. We could use multiple databases. We can synchronize that with some CDC, with the message queuing, etc. And by that, we, of course, are getting the eventual consistency. But again, the choice is not because we are using the CQRS, but we are able to do it efficiently because of the CQRS. And this is our choice and our optimization. So it's not mandatory. And about the eventual consistency, should we be so scared about that? Well, not precisely, because optimistic concurrency can help us in that. If we are getting like a details view, and we would like to get some money from the withdrawal from the ATM, then we could get from the read model our current version of our entity. So wherever we are changing entity, then we are bumping, auto-incrementing this version. And when we do that, then if we send this version together with the update request, then database and most of the major tooling allows us to send the version, and then this database will verify whether this is the same version as we have in database. And as write model typically should be implemented on the database that have the strong guarantees, then we should be fine. Because even if our read model, so like we have here, have the obsolete version and we send it, then our write model will guard us and will tell us that, yeah, this is not the version that we expect. This is too old. So after that, we can retry that. We can do yet another fault tolerance mechanism, but we have more options and we have our business logic guarded. So it's not like we are getting eventual consistency. And also we should not be scared about the eventual consistency because that's how the real world works. So we are getting, as I mentioned, in the end, we can keep this strong consistency. So is there a CQRS without event sourcing? So I already showed you that because we don't need any events, any messaging. We could have, and event sourcing works extremely well with the CQRS because if we have the command and we have this command gathering some specific business intention, then it's totally fine because then we can record the specific new fact of what has happened. And that's how CQRS helps a lot event sourcing, because event sourcing is how we are storing and how we are processing our business logic. It's not about moving data from one place to another. This is event streaming. Event sourcing is about recording facts and then running the business logic based on them. So the first step that we are doing in event sourcing, we are getting all the events from event store, and event store is type of database, not type of messaging tool. And then we are running business logic, and as a result, we are getting another event that we are storing. So I'm always joking that CQRS and event sourcing is like a citron and the tequila. It works, they goes pretty well together, but you can do CQRS without event sourcing. Event sourcing without CQRS, it will be much harder, but CQRS is totally fine without event sourcing. And yeah, so where this comes from, because in event sourcing, if we are creating read models, then we are most of the time storing it as a flattened version, somewhere as a projection. And because we are publishing events and many people are using event sourcing together with CQRS, then they are usually trying to explain event sourcing and CQRS together, which is one of the main issues that I see, because it's not helping in adoption any of those patterns, because people tend to don't understand the difference and think that you will always need to use it together, but that's not correct. So does CQRS requires Kafka or Rabbit? Of course it's not, because you still, oh, sorry, Polish language, you can learn a bit. So you can use CQRS and events that were created, as I show you as the last step here. So you can publish a domain event and then use it to, for example, build a local representation, like a local read model in our microservice, or we could use those messages together with outbox and inbox pattern or messaging platforms to integrate those two services. But you don't need to. If you can do CQRS with the monolith without messaging, it's up to you to decide. So does CQRS adds overhead to the implementation? I don't think so, because there is a term cognitive load, and cognitive load was coined in the 80s of the previous century by John Sweller. So it's like a cache in processor. I mean, it's kind of funny that I'm explaining the human brain to other humans by using the processor metaphor, but it's like that. So we have cache, and in our brain, we also have cache. So the amount of information that we can keep at the same time. And if there is too much information, then the cache is cleared and we are not able to keep those informations. So if we need to absorb, and always remember where to put what and try to understand, especially the much more complex code base, then it's making not effective. The constant context switching, the number of layers, it's making harder and harder to understand, especially for the new person, how our architecture is working. So in my opinion, if we are slicing vertically our domain and we are focusing on the specific business operations, then it's much easier to understand, to reduce the context switching. So the summary. I hope that I was able to show you that CQRS is not as difficult as its picture. In my opinion, it's really simple pattern. So it's about segregating operations based on their behaviors, splitting writes and reads. Or writes is not totally precise, business logic, because the result doesn't have to be right. It might be publishing events, storing, generating PDF, whatever, doing something, and reads. So by doing something, we expect some side effects. With reads, we don't. So that gives us better predictability, focus on the business. So we are also learning the business logic while reading the code. We are getting much more options to evolve, to scale, to change our model in the future. And we are understanding our system and our architecture better. So I hope that if someone tells you and that CQRS requires multiple databases, message bus, event sourcing, or eventual consistency, then you will say them that no, the neat part is that you don't need all of that. If you'd like to, you can even do CRUD and CQRS. Of course, I don't recommend that, but as I said, you could use like base classes for majority of CRUD services, use aggregates wherever that fits your model and gives you more options. And yeah, so that's all about CQRS. And thank you. And questions? Do you have questions, concerns, or your thoughts after this webinar? Do you still think that CQRS brings additional overhead, or are there those myths still valid in your head?
So maybe I will add something. I'm using CQRS or maybe this approach since I would say there will be 7 years, and I can imagine how to not, maybe in other words, CRUD, I would say that it's very flexible because now currently I more approach no code or low level code approach. So I wouldn't say that in CRUD I would use the code, or maybe I would try to use CQRS because there are a lot of new frameworks which can generate code from the scratch. So I would probably totally skip everything related to the code. But in more advanced code, like using some business logic and something like that, I would say that CQRS it's more like how to good split, how to optimize, or will be better how to optimize system and separate something which should only be an action. And of course, I am this person who don't be totally for that command shouldn't return anything. I think CQRS is a very flexible tool which allow us to do a lot of things. But in my opinion, I would say totally that in more business logic, then should be more CQRS in CQRS. So in this case, yeah, I will agree with you. But to CRUD, I would totally skip everything mostly, and I will use some Kazura or some other tool which only generate me code.
Yeah, thank you for the feedback. I think that what I would like to also highlight here is that if we are going with the CRUD, then typically when we are looking at the new domain, then it looks like CRUD. Everything looks like CRUD. And sometimes it is at the beginning. So there is no point in like making the heavy investment in some code structures. But that's also the reason why I showed that we should be cutting as many layers as possible, because then it reduces the additional overhead, and our code is still simple, and it's much easier to compose this explicit part. And by saying that it gives us more option, it's also important, in my opinion, to also think about that since the beginning. Because if we start with this generic code, then it might be harder to evolve in general, because I think that any of us was at least once or twice with the big ball of math, and big ball of math is happening like every day. You are just adding yet another if, yet another base class, and it's growing. So I agree that it requires some rigor and consistency, but I think that it's not much more code, and much more complex. And if we start with those simple code and simple explicit code, then it should be easier to evolve when there is time. Because as I mentioned, when we are starting project, then we are usually the dumbest during our history. And unfortunately, at that time where we are dumbest, then we are making the most important architectural decision. So that's why I believe that it's good to not block ourselves and open more options to ourselves. So that's why I think that starting with CQRS, it's okay to just start more explicit. But yeah, I mean, that's my point of view, and I fully respect what you said, because that's also valid. I'm just saying that I would like to highlight that we should also think not always what we have right now, but what we have in the future. Of course, not to over-engineer, but to open as much doors, or leave as many doors open as we can.
But there is something very dangerous, because first of all, when you think about data, okay, so there is hard to say, but if you discover a product and you didn't find nothing more than data on data structures, in my opinion, it's something more to split the product as a simple GraphQL or some existing like low code or something like that. And in future, when we discover some business logic, we can try to build some special extended, for example, Lambda function, or maybe some code. In my opinion, I would say, in my experience, more or less, it's sometimes there's something like specific domains which will appear in the future, but I would say that my current approach is something that I will create very fast and simple MVP and use it like a normal verification to for example, to user or the mobile application. And other way, there will be something, there will appear something related to the business logic. I will start to, for example, build a second application, which will maybe in future replace or maybe only focus on some domain. And here, that's the reason, like very like serverless. I really like the approach that there's some maybe general application which cover some CRUDs, and every new Lambda and every new Lambda, in my case, and every new function will new service will cover a new domain. And yeah, but in normal code, I will probably do the same, that there will be two applications. One run some basic I really like Zura. I really recommend you to check for or some other no code or low code application. And when there will be in future when we will discover some business logic, yeah, I would treat something like proxy maybe, and I would start to split this separate these two separate things. But in my opinion, it's very easy to add new table, and there will generate new for example, endpoint, and verify to the end customer.
Yeah. Thanks, Wojtek, because Wojtek is leaving, so just saying bye. And to your point, Mateusz, I think that I agree. I'm also all for the quick feedback with the user. So feedback loop is, in my opinion, the most important. The only thing that I would, if we would like to start really that simple, then the only thing that I would for sure recommend to do or suggest, maybe not recommend, but you probably do that already, is to note those business decisions or technical decisions. So why did you choose to do that? Because then you will have, at least for future you or some other people, like, yeah, this is the border that I don't want to cross, and this is the limitations of the current solutions, and this is what I recommend to do if we reach that point, like, you know, have the problems that we would like to have. Like, what I mean is that we already succeeded, and we have much more traffic that we expect, and our business logic needs to enhance, then at least that we have some plans and that we have those risks measured and accepted. So what we are agreeing. Thanks, Citelo. Thanks, Rafał. Thank you for joining. Yeah, so Mateusz, but in general, I agree. I think that this is just a slight difference. Thank you a lot. I really like when someone is challenging me. If everyone agrees, then that I'm getting suspicious.
There's no one here.
Yeah. Thanks.
So thank you, Oscar. So I will, yeah.
Yeah, so don't stop to do that. Okay, any other questions or comments or feedback?
We have Oscar only to us.
Okay.
So.
Okay.
And it's recording, so. So thank you very much, and see you. Bye.
Yeah, thanks. Bye. I hope that it recorded fully. We'll see.
Me too.
If not, I will need to re-record it some next week. Have a nice evening. Bye.
You too.